So welcome everybody to today's session on prepping for Black Friday. I'm Michelle McLean, VP of Marketing here at ScaleArc, and I'm very excited to be joined today by Craig Thayer. How are you?
Good.
Good. He's sitting here with us live today, which makes this a lot easier. Craig is the CTO for an e-commerce company called Sazze, and while the parent brand isn't as well known, many of the sites that Sazze runs are quite well known. And Craig has the special joy of dealing with some sites that have very dramatic traffic swings around Black Friday. So we see these horror stories every year. There's always at least a few companies that have really painful experiences on Black Friday. Last year it was Macy's with its famous website warning saying, "We just need you to wait 10 seconds to come onto our site." A couple years ago, Neiman Marcus was offline for 36 hours straight. These stories happen way too often, and we sort of laugh because everybody knows Black Friday is coming, and they should anticipate this, and of course they have, right? Of course the team has taken a lot of steps, but something got missed. And so with that introduction, I'm going to kick it off to Craig to share a little bit about Sazze as a company and about how he tackles things all through the year. Thank you so much, Craig.
Oh, you're welcome. I'm happy to be here. As Michelle said, my name's Craig Thayer, and I'm CTO of Sazze. I'm excited to be here today to hopefully share my knowledge and experience that we've had with Black Friday over the years with you guys, and hopefully it'll be helpful for you. Sazze, as Michelle said, is a parent company to several e-commerce sites. They all have different traffic patterns. For the focus of today's talk, we'll focus mainly on Deals Plus and Black Friday FM, which are our two most popular sites, and they're also the two sites that are affected by Black Friday the most. We started off on-prem, doing traditional colo install, servers, and all that fun stuff, and then we've recently moved into the cloud in order to leverage those technologies. So we'll talk a little bit about both of those scenarios. We tend to be a shop where we build versus buy, with some notable exceptions, but so we use open source a lot and leverage that wherever we can. And then in terms of the Black Friday traffic swings, Black Friday FM is our most affected site. It essentially has no traffic at all during the year, and then on Black Friday itself, you know, we have like 4 million people come to the site. So it's a very good case study for extremes of traffic, and we tend to be hit a little bit harder than a lot of the companies because our particular sites, Deals Plus and Black Friday, both aggregate the deals that are going on for all the merchants. So we're not just Dell getting traffic to Dell because Dell has great, you know, deals. We're getting traffic from Dell and traffic from Neiman Marcus and traffic from Macy's and traffic from Kohl's and traffic to Amazon because they all have great deals and we have all that stuff there. So we tend to see even a little more dramatic traffic swings than even the retailers do. So
yeah, on the Black Friday app, you were saying that that goes from like nothing to being one of the most popular apps on iPhone every year?
Yeah, so we've been in the top 10 free apps on iPhone pretty much every year. The number 3 spot was our best one a couple of years ago, right. And that's fairly insane too. So,
cool.
So this is not a terribly detailed depiction of our architecture, but it gives you a little bit of an idea of kind of what we're doing. It's pretty standard. Right now we're all in Google Cloud. We've moved everything over to there. And, you know, it's a typical application web-hosted service. We have our application servers. We have our caching layer, CDN. We have our non-SQL data stores like Elasticsearch and NoSQL, you know, unstructured NoSQL data. And then we have our SQL, where we use Percona XtraDB cluster, which is MySQL with some multi-master semi-synchronous replication setup. And I listed out the separate databases there for Deals Plus and Black Friday. In the data center, we were more shared, like this picture depicts. In the cloud, we're more siloed, so they don't share application servers and things like that anymore.
Okay. We had a customer forum yesterday, and we're talking a little bit about cloud in that group of folks, and people were making the observation that a lot of different factors come into thinking about cloud. Can you share a little bit about, you know, why cloud? I mean, you're highly elastic, which would make sense for cloud, and just a little bit about any surprises or any advice around folks who are thinking about cloud for this context?
Yeah, so cloud is a different mindset. In the data center, the costs are more fixed, and a lot of times much easier to predict because your equipment costs X, your people cost Y, and you kind of put those things together and you have your expected costs. And there's a lot of places in the data center where you can kind of essentially get things for free because you need X amount of capacity for whatever reason, but you don't use it all the time, so you can use it for something else when that capacity is not needed, and it doesn't cost you anything extra to do that. In the cloud, everything costs you money all the time, so you kind of have to be much more conscious of, you know, making sure that what you have provisioned in the cloud matches what you need at that moment in time. And that's where kind of the scalability comes in, because you need to be able to scale down just as well as scale up in order to kind of manage your costs and make sure that you're not spending money that you don't need to spend. That's more the financial side. From the technical side, we found that a lot of the challenges are the same as building out a data center, but the tools are different and the things that are available to you are different. So you end up solving a lot of the same problems that you solved in the data center, but you have to solve them in different ways using different tools. And different cloud providers, they're fairly similar, but they're all a little bit different too. So, you know, we had some trouble where with Google where things didn't work quite the way they were supposed to work. Documentation didn't match actual implementation, and it went both ways. Sometimes it was old and the documentation didn't mention features that were currently available, and sometimes it seemed like the documentation was written first and the features hadn't quite caught up to the documentation. So there's a lot of trial and error involved in that kind of stuff.
Okay.
But, yeah.
We've had one question come in on your previous point on the financials. Have you found any good cost estimation tools online?
That is a great question. I would say that I have not found any great tools online. I think that Google's recent cloud conference, where they had an entire session track devoted to how you calculate costs for their platform, speaks to how complex it really is to figure that stuff out. As kind of a rule of thumb, what we've found to be the most expensive is the CPU resources and the SSD storage resources, with memory coming in kind of third. So that's been our experience with it, and we just try to, you know, keep those as low as possible. But so even now we're still reacting to price versus being terribly accurate at predicting what it's going to be. Kind of the ephemeral things like network traffic and things like that, don't play that big of a role overall in the overall price structure. Those are the hardest things to predict too. So, but usually the other costs dwarf the actual network traffic costs, at least in our experience.
That's great.
I guess we'll start in the Q1 or in the all year round, you know, what are we always doing sort of thing. And basically, my philosophy is, you know, everything has to be highly available and everything has to scale. And to me, vertical scaling is not scaling. Vertical scaling is band-aiding and patching because it's not sustainable. You will much more quickly reach the point where you cannot go any bigger in a vertical scale versus horizontal scale. So basically, we're always kind of evaluating our architecture for where are the places where, you know, we don't scale the way we want to scale because unfortunately not everything scales the way we would like it to. And we, you know, look for how we can avoid technologies that don't scale. You know, we put some effort into figuring out different ways to do things to avoid technologies that don't scale. You know, horizontal scale is all about being stateless. Everywhere you have to share state is a place that makes it hard to scale horizontally. Big reason why the database is the traditionally and I think contemporarily hardest place to do horizontal scaling is because that's where all the state is shared. And so as we remove state from everywhere else, applications still need state to actually provide services, and that usually falls on the database when we get rid of it from everywhere else. So if anyone comes up with or knows of a database system that manages to act like a stateless system but shares state, you let me know. And then we're always evaluating for, you know, the pain points in our system, you know, things that are unoptimized, hotspots, distribution of traffic, things like that. And then yeah, this last line on there is probably more appropriate, actually, now that I really look at it, for the November section. But I'll speak on it now since it's here. So basically, you know, sometimes you have to do what you have to do right now. And, you know, in a pinch, we'll do something that we know doesn't scale. We know we can't maintain it long term, but it'll get us through today's problem, and we can fix that tomorrow. And in terms of Black Friday traffic spikes, sometimes you don't need to fix it tomorrow because tomorrow the traffic's all gone and that Band-Aid did its job and got you through the, you know, pain point in traffic spike.
Okay. There's a quick question in here about load distribution.
Yes.
How do you try to design for evening out the load distribution, and where does that not work?
That's a great question. So in our architecture with the web app, we try to make sure that user requests are distributed across application servers, and any other internal requests that application servers may make are distributed amongst the internal systems that they require to do their job. And we typically use some form of load balancer to do that. So in the data center, we used F5s and things like that to do load distribution. These days, we're using a combination of HA proxy on the actual application server itself, and then a service discovery tool like Console in order to discover the various services that are out there. And then at the end of the day, it's about kind of choosing the load balancing algorithm that matches your traffic patterns in order to get the traffic actually distributed across the various upstream services where that traffic is going. So sometimes I think as a rule of thumb, probably the least connections pattern is what we tend to do more often than the other ones, but it really just depends. Sometimes a real simple round robin works better in certain scenarios, and for actual like web user traffic, the cookie based load balancing at layer 7 is the most effective at distribution, because it allows you to load balance every client to a different machine instead of everybody who's behind a specific IP address going to a certain place. So we try to get as granular as possible to get down to the actual user request itself to split them out across the various machines. And that just depends on what your application does as to what the best way to do that is.
Right. Great insights.
So essentially, as Michelle mentioned, we're going to start the clock in December right after Black Friday and work our way around. So December is our post-mortem. So all the Black Friday traffic, for the most part, is already gone. We still have higher than usual traffic during this time because it's holiday shopping season still, and as more and more holiday shopping is done online, we maintain more traffic after the Black Friday time period, but it's actually relatively relaxed, because after doing everything we had to do for Black Friday, even though traffic level is high, it's still really low compared to November. So it's relaxed, and this is the time period where all the crazy stuff that we had to do during Black Friday is fresh in our minds, and so we take this time to kind of go back over everything that happened, kind of replace or remove any of the Band-Aids that we put in place that we knew we weren't going to keep long term, and then we decide, you know, what do we actually need to fix for next year, and kind of start thinking about how we're going to do that. And so basically, Q1 and Q2 are spent implementing those fixes that we need to fix. They're also when we make feature changes and design changes to the applications and to the infrastructure. And so this is kind of our R&D period and rolling out of new major features, which gives us some time to launch them and see how they react, not only on a user side, but on the infrastructure side. You know, what new kind of demands do they place on the infrastructure, and how do we adjust for that? And it gives us some time to experiment and plan before things get real crazy.
See, we're kind of in this time frame right now.
That's correct.
What are some of the things that you guys are working on in your system?
Well, I can't speak to the features that are coming.
That's fair.
But on an infrastructure side, we're actually doing a lot of research into and implementation of containerization. So now that we're in the cloud, you know, it goes back to economics too. So in the data center, your unit of work, per se, is the actual physical server. And in order to optimize the use of those resources, you virtualize so that you can split those physical units of work up into smaller units and make better use of them. In the cloud, your base unit of work is a virtual machine. And so in order to get the same level of optimization out of that resource, you need to take one step up above that, and that is the container. And so we're looking to further kind of optimize our cloud deployment by moving to a more container-based model. And that's where we're putting most of our infrastructure effort into at this moment. Cool.
And to do that, is that a lot of app rewrite? Like, or what does it take to do that?
That's a great question. I talked about the cloud being a totally different way of thinking. Containers are a totally different way of thinking from VMs. So I think most of it is just changing your mindset. That's always the hardest thing with all these different technologies. You got to change your mindset so that you can approach the problems from the point of view of the different way that the technology is used to solve the various problems. And so it does require application changes. It requires a lot of infrastructure changes. Because sometimes, like, we've found a lot of cases where the way we're doing things right now that works really well doesn't really work so well in a container model. Or we'll say, oh, the container model already has some of these features that we had to build ourselves into these other things. So now we have duplication of features, and we have to decide which one do we want to use, do we want to keep doing what we know works, and does that make sense in the new model? So there's definitely a lot of changes that are involved in that. I think in the end it's going to end up being probably a better thing, especially since, you know, for the foreseeable future we'll be living in the cloud. So.
Yeah. Okay. Very cool. Great tangible example.
So August to November is kind of, that's the important time. So August is the beginning. So for us, we tend to see traffic start to ramp up from the Black Friday shopping season in around September. But August is when we kind of start saying, okay, this is Black Friday game time. We're going to start making that the priority. So basically what we do is, starting from August, we do our absolute best not to implement anything that's radically new. We make sure that we put the finishing touches on everything that we have started in Q1 and Q2, and we make any final kind of large changes that we feel are going to be necessary for Black Friday, because we still have a few months to do that in. In early November, we put a freeze in place on the applications. That's quoted for a reason. You know, there's always something from the application side that needs to change, because every Black Friday is different. Merchants do different promotions, different years. They try out different strategies to get more people to come to their websites for Black Friday. So, you know, sometimes there's, over the years, you know, at first you couldn't get doorbusters online, right? Which, for those of you who don't know, doorbusters are things that you get when you are one of the first people through the doors of a retailer. So they have special deals for the people who wait in line, you know, for 24 hours before Black Friday, things like that. And so, you know, about a year or so ago, you could actually get the doorbuster deals online. And so now we have, you know, kind of a new class of deal to promote during that time period. And so you kind of never really know when that's going to happen until it happens. And so, you know, sometimes we have to react to that kind of stuff and make changes during the quoted freeze. But we try really hard not to make any feature changes during that time. Basically, in this time period, we're watching and predicting and reacting, basically. So we're watching everything real close and making sure that we make any changes that are needed to weather the change in traffic pattern that we expect to see.
We've had a quick question come in on the freeze question. Can you give an example of something you've said no to? Too risky, or, you know, I don't know.
That is a great question. Unfortunately, I am not the person who enforces the freeze. So,
so if it makes its way to you?
If it makes its way to me, I almost usually at that point, it's we need to do it.
Okay.
But for the most part, I think I've been lucky in the sense that we really haven't been asked to do things that weren't necessary for the business. I guess not a direct answer to that question, but I have pushed back. So starting in August to do all the stuff is something that I've pushed into place since being at Sazze. We used to start later in the year, and it was much more hectic, and so I've worked to push all that kind of pre-development work back to the August and September timeframe, which originally we used to do in October and even a little bit of November, and that was just crazy. So.
That's a great response. So just changing the timing of when kind of the mentality of lockdown.
Yeah, because I mean, if we're talking about Black Friday and we talk about Black Friday FM, right? This is a site that has no traffic during the year, and all of its traffic is in October, November, basically. And so from a business perspective, it doesn't make sense for us to work on it specifically all year long because there's no payout for that. So we put our efforts into like Heels Plus that gets traffic all year round and then gets the spike at Black Friday. Yeah. And so the mentality was kind of like we need to make Black Friday FM do what it needs to do, but we want to spend as little time as possible doing that. And that kind of originally had translated into we're going to start in October making all the changes that we need to make. And, but it's like, well, so I got them to kind of push that back and say, you're still spending the same amount of time, we're just doing it in August and September instead of October and November, and it makes the October and November time period go much smoother because all the major features are in place and things like that. And at this point, our system is flexible enough that we don't need to make major feature changes to do things like add a new class of deals, right? We just say, here's a new class of deals, and we have our, the system is designed to be configurable so we can promote certain things more than other things, and that kind of stuff is already done, so we're not having to change the system itself to do those kinds of things anymore. And yeah, mostly what we're looking for in August and November is the hot spots, basically. So we're pretty good at predicting how our traffic is going to change over the time period, but every year is subtly different. And because we've made changes to things that are on the sites, there's different, usually different pain points every year. So, we just watch all these things and make sure that our traffic is being distributed appropriately, make sure that we're not reaching any limits faster than we expect to be reaching them, and just generally try to use the previous year's traffic pattern as kind of the template for what we expect to see this year, and then whatever else is going on in the space to kind of predict, what our consumers doing, what our merchants kind of hinting that they're going to be doing, is it predicted to be substantially bigger this year than last year, things like that.
There's a question that has come in around monitoring. You've talked a few times about looking at things, monitoring for things. This person's asking, what are some of the tools that you're using for monitoring?
Great question. Currently, we're using mostly Datadog for our cloud monitoring. In the data center, we used some internal tools, Ganglia for one, and Agios and things like that. There's a lot of them out there. I rather like Datadog. They fit most of what we need for the most part. We haven't had to use a bunch of other stuff. They have a bunch of competitors too. I'm sure they all do the same thing. So if you don't mind Well, that's the thing with the cloud. So, like I said, you kind of pay for everything in the cloud. So, you either pay some other service to do monitoring for you, or if you build it yourself in the cloud, you're still paying for it because you have to pay for the machines that it runs on. Whereas in the data center, that's kind of one of those things you can sometimes get essentially for free because you just use some of your excess capacity to run your monitoring systems in. Although monitoring itself can get to be quite a system, but it's usually not bigger than the actual systems that you need for your own stuff. So we were always able to use excess capacity in the data center to run those things, so they were kind of free if you're not counting manpower costs, but the manpower costs are always there, even in the cloud. Unless you have a very simple application, there is no click and it's done sort of thing. Like, I know they try to make it seem like the cloud is, but yeah, I think move on. So, you know, even though my philosophy is everything has to be scalable and, you know, we try to prepare for everything, you know, sometimes it pays to do things that are risky. So sometimes that means a last minute application change after the freeze because, you know, there's this new feature that needs to be added because it enables a much better user experience or enables better SEO to bring traffic to us, and that pays off in a big traffic spike. If it makes a big traffic spike, even better, as long as you can handle the excess of that spike. You know, part of that is also deploying what we call Band-Aids, so, you know, solutions that are not scalable and not, but they serve the purpose of floating the site through the brief traffic spike in order to make things happen. So kind of as an example of that, we had one year where we got way more traffic than we were expecting to get, and we were maxing out our F5 load balancers. They were just about ready to drop us or start dropping connections because they were getting maxed out, and we didn't have time to buy and install upgrades for them. So we rolled out some HA proxy servers to augment the F5, use DNS load balancing to point to these things that were not highly available. So if they had a problem, you know, we would have had, you know, X fraction of our traffic that was getting pointed to them wouldn't go through, but that didn't happen. So because the time frame we ran them in was so short, we decided that the risk versus reward was good enough to take that risk, and we got lucky, and we had no problems with the servers going down, and we didn't lose any traffic, and we were able to keep all the traffic from that time period. And then afterwards, yeah, we upgraded our load balancer so that we could handle more traffic. Right. But that's just an example of kind of a Band-Aid that paid off for us. So it's always kind of, when you're in the spike, it's always risk versus reward because it's a short period of time. And so you can get away with stuff that you couldn't necessarily get away with over a long period of time. And you know, it's something where if you don't grab it today, then you've missed it forever, sort of thing. So, you know, a lot of times places say, you know, well, it's one day, right? We'll get as much as we can possibly get on that day, and then that's it, right? I understand the economic thinking behind that, right? Because it's like, well, why do I build an entire data center that I have to pay for every year, all year long, and to be a high enough capacity to handle one day out of the year, right? we've been kind of lucky because we run multiple websites with different traffic patterns, and so we needed to grow our data center regardless for Deals Plus as Deals Plus grew, and Black Friday got to take advantage of that. So whatever we built up for Black Friday inevitably got consumed by Deals Plus during its growth phase. In the cloud, you don't have that excuse anymore because your capacity is whatever you need it to be on the day that you need it there. So the challenge is not to build an architecture that can handle your one day of traffic. The challenge is to build an architecture that can be tiny, almost non-existent for most of the year, and then can grow in an extremely short period of time to handle all of your traffic needs for that day. Because if your business model is set up correctly, you should make money from all of that traffic. So every dollar that you capture on that day is some form of it is profit, right? So even if it costs a lot to run that infrastructure on one day, you got a bigger piece of the pie as well. And so you know, you kind of got to balance that mentality of just calling it a day when things don't work and actually architecting to capture the entire spike. When I started at Sazze, that's how we were. It was, you know, we did what we could, and I mean, we had like no budget or we had no nothing, so, you know, it wasn't really, we didn't really have the ability to capture the entire spike when I started. And that's what we did. We just said we'd give it our best shot. When everything goes down because we can't handle the traffic anymore, then we go get something to eat, you know, because there's nothing we can do. Right. And, you know, that's kind of what I changed at Sazze. We were my team and I were able to actually architect a solution in the data center first and now in the cloud that enables us to be cost effective when the spike is not going on and still capture the entire spike during the traffic time. And kind of the way you do that depends on what you have available, or, you know, how your business operates, right? So, and then I guess we talked about the cloud already, implications of the cloud. I know it's talked about a lot as a black and white kind of economic decision, but it's really not. If you take an existing infrastructure and transplant it to the cloud, you will inevitably pay at least 2 to 4 times more for that exact infrastructure. So you need to re-architect the way it works in order to make actual economic use of the cloud, in order to see the economic gains from that. And besides the technical reasons that you can't do everything that you would do necessarily in a data center in the cloud, you have to re-architect that way anyways. And then, you know, staff is still required for the cloud. The skills change a little bit. You know, we don't need people to spec hardware and purchase it and rack it and stack it and connect it, right? But we still need all of our operations engineers. We still need all of our system administrators. But we were a pretty lean organization. You know, we had 1,000 some odd servers, and we had 2 guys that ran the whole data center because we were that automated and that lean. So our staff size didn't change at all going to the cloud because they were all administrators anyways, and you still need at least 1 or 2 people to manage your cloud presence. And so, but the difference is, you know, that time that they spend doing all the physical aspect of the data center translates into time spent doing more scripting and automation work. So sometimes your staff members that are more skilled in the physical architecture work don't necessarily want or have the skills to do the automation, scripting, and things like that. And so, you may need to switch them out for people that are more focused in that area.
That's a perfect introduction. This comes up a lot in our customer conversations around the cloud and using the cloud and which problems does the cloud solve for me, and basically your point that you still need all your systems admins, you still need your ops engineers. I think at the technical level it's well understood. I think the challenge can come at the business level when people are a little more removed from the reality of it all, and there's this idea that the cloud will sort of solve all the problems. So what we've observed, and I'd love to get your feedback on some of these things, is that the cloud in some ways introduces its own set of challenges, and we have a few of them laid out here. Certainly you're moving from bigger servers to horizontal scale out, which is an architecture you've always followed, or, that's driven you a lot. But for some people, right, that app was written for one big server, and now you got to go try to figure out how to have it talk to smaller servers, and that can present a challenge. We've certainly heard folks talking about I/O limitations. You bottleneck in different places, and none of that stuff is. And as you said, it can be really pricey to try to replicate some of that, like at the SSD level for storage and things like that. That can be challenging to try to replicate. At the hypervisor level, we're hearing around, it introduces its own steps in the process, and the bad neighbor effect that you kind of don't have any control over. You don't know who you're going to be co-located with in the same resources, and that can be a challenge. And then you don't get control over where certain resources are deployed, and so you can have more latency in the traffic flows. And then, as we just saw with the Amazon S3 outage, right, they still can have their own problems for any multitude of reasons. But beyond the unplanned outages, we've also heard about maintenance that the cloud folks call being a challenge for certain companies. And then again, in yesterday's customer forum, this person brought up the fact that they use on-demand resources versus reserved resources, and he was saying multiple times recently he's gone in to go add capacity, and he can't add as much as he wants to add. So just curious, how does some of this sit with you? What have you, I'll talk a little bit about how ScaleArc can help with some of this stuff, but what have you seen in terms of trying to mitigate some of these things?
I've seen all of it. So coming from the data center where we control everything, we did whatever we needed to do, right? If we needed better I/O, we put in better I/O, or we, architected the app not to use I/O in those situations. For bad neighbors, right, we had control of that. We never oversubscribed anything that was production. Staging and development, oversubscribed out the yin-yang, right? But production, never. And network latency, we were sub-millisecond everywhere in our architecture, so we essentially had none. And uptime challenges were all our own, right? So we cause them, we fix them. In the cloud, the VM pricing is definitely, something is a bit of a challenge. We have to do some app re-architecting because we had kind of architected the application to run within a certain, unit of size that worked really well on our platform. And then in the cloud, it's kind of like, well, that size chunk is kind of pricey, so how do we make it run in a smaller footprint that we can have more of? This is also kind of ties back into why we're trying to go into containers so that we can, actually make use of a larger sized VM but have less of them, because even running a lot of small VMs gets pricey pretty fast. So in some instances, having a smaller number of a little bit larger VMs that you can slice up amongst a bunch of different things is better use of the resources. And again, it just kind of depends on finding that sweet spot for your application of what does it actually need to run and what combination of resources makes the most sense from a cost perspective, because there are sweet spots. Yes, as the machines get bigger, they get more expensive, but it's not linear, and it's not a nice smooth curve either. So the slope of the curve changes as it goes through the different sizes of machines. So sometimes they increase linearly, and then they stop increasing linearly, and they slow down a little bit, and then they'll start going exponential, and then they'll start going linearly again. And
so you're looking to maximize sort of the end of those flat points, or those nearly flat points.
Exactly. So you want to
hit.
Pick the sweet spot for your application, and every cloud provider is different. They do change their pricing too, so it doesn't always stay the same, but that's, I guess, where that is. So in the cloud, you have bad neighbors all the time. I don't think I've ever seen a single VM we've ever run that hasn't had CPU steal going on to some degree, always. Usually it's small enough it doesn't really make that big of an effect, but it's there, and you never really have any control over what it's going to be. I think in that sense, it's important to monitor your application performance so that you can either route traffic around slow-performing machines or drop them entirely and recreate them, because they'll probably appear somewhere else, and you know that's your roll of the dice as to what neighbors you get.
Right.
Network latency is something we struggle with in our automation. Google's network is, I'm going to say, unreliable. A lot of times it takes 2 tries or 3 tries to do something from an automation standpoint, whereas in our infrastructure was always a one time, or there was something that was seriously wrong going on, which I think is just a function of, you know, the way their network is designed for the scale that they operate at, and, you know, making it a shared platform for people. But if you look at all their tools that they provide, all of them will retry several times before they give up and fail, and that's for a reason.
Interesting.
And they all have uptime problems, every single one of them. Google had, you know, after they kind of got to have their cloud conference right after Amazon's big public mess up, they had major network outages 2 weeks after that for several days, only 2 of which got reported. So that is the other thing, is that they all have a sliding window of, if the problem resolves itself or we fix it within a certain time period, then it never happened. And depending on what your uptime requirements are, that can be a really big deal or not so much of a big deal. So they get to go tout their big, you know, 5, 6 nines of uptime when, you know, your site was down for 5 minutes. And
that's funny.
If 5 minutes in the middle of the night, maybe not a big deal, right? 5 minutes on Black Friday, really big deal.
Somebody at the forum yesterday was saying that, I won't name names, but that one of the cloud providers, there's, you know, I don't know this math instinctively, but there are 8,760 hours in a year. And he knows that because he's been running all of his systems and all of his SLA metrics against that. And the math that this particular provider uses, there are magically 9,000 hours in the year. And so their SLA stats look a little better because they added some time to the earth somehow. So definitely seen things like that. So I'll touch on this very, very briefly because we're running short on time, but, you know, ScaleArc's really focused on improving uptime and performance. And I know for your guys' instance, for example, you have migrated the ScaleArc platform with you from prem to cloud. But, you know, very quickly, our ability to load balance the traffic across smaller instances means that migration to the cloud doesn't have to force app changes. We can help you grow a little bit more linearly, and as you add that capacity, you can do so without taking down the app because it's transparent to the app. We will be monitoring performance of any server, and so we will route around those servers automatically. So we'll do that on behalf of the app. The app doesn't have to be doing that. And, you know, on-prem, that translates into replication lag. In the cloud, that can be things like this kind of delay. And then we're geo-aware in where we choose to send resources. So we'll keep traffic local as much as possible. So even when your database is spread out, we're going to keep the traffic as close as possible. We can also have a caching layer that sits close to the app and removes some of that latency problem. And then our ability to do app transparent failover is a huge benefit. So I'm going to go really quickly through the last couple of things that we've seen. You talked a lot about, you can't have those 5 minutes of downtime during Black Friday. Huge use case for us is avoiding that kind of downtime. We're seeing a lot of interest in moving to active-active operations. You guys were very early on with that. MySQL in general was earlier with that than a lot of other databases. And so, what will happen is the read-write split, we're doing that automatically on behalf of the app, so you don't have to program the app for horizontal scale in the first place, but then we will detect if that primary is going down. We'll queue the writes, hold those so that we're aware of the status. We're waiting for that secondary to be ready, and then while that's happening, of course, the app's not getting errors, which is good, and read traffic can keep going to the secondaries. Then we'll drain that queue in a FIFO manner. And so it's just a lot more elegant for the apps because they've seen delay but not errors, and they handle that a lot better. And we have a whole white paper around the hidden cost of DR, and this is its own topic we'd love to delve into. But basically, research is revealing that people think about the software cost of moving to active-active because now you're having to pay for that database license, which if you're coming from like a SQL Server world where it was just an idle secondary and was only getting hit in a DR instance, that software uptick can be a big deal. And so people will kind of mentally say, oh my gosh, my costs are essentially going to double. But they're really not. We're finding it's about 20% more cost to move to active-active architecture because you can scale back on the hardware side, and that'll a little bit mitigate your increased software costs. But with that, you're getting a 33% increase in capacity, and then a whole bunch of operational gains. So we're right against the hour. Let me just check over on the questions really quickly. You talked a little bit about staffing, the fact that you still need your systems engineers and all that. Can you just talk a little bit about how you've done workload allocation across your team as you think about this whole calendar approach? Who works on what and how much time? I mean, Black Friday can't be the only thing your team does, so how do you allocate workload?
That's a good question. So I think it boils down to a similar thing for all teams, right? So in our organization, the development teams and the operations teams are one and the same. Obviously, they have different skill sets, and they do different types of work, but at the end of the day, both of their skills are necessary for us to actually do what we need to do. And so we kind of, we decide what needs to be done. I'm the primary architect, although all my team members have input into the architecture of different features. And once we decide what we're going to do, then we figure out what work needs to be done, and we give that work to the people who we feel are the most appropriate to handle that work. Okay.
It sounds like overall you're not super siloed, so people have a lot of...
Yeah, okay. We're not super siloed. We try not to silo as much as possible because, one, we're still small enough where everybody can be, for the most part, in the same area and talk to each other all the time. And, two, they're really not separate things. They both need to work together, and when the people work together, then the software and architecture works together better too.
That's great. Well, that sounds like the perfect place to wrap. Craig, thank you so much for your time today. Really been great to hear all your thoughts and get this advice for folks getting ready for their own Black Friday or other traffic surges. So thank you so much for your time. Really appreciate it.
Well, I appreciate you having me on, listening to me talk for so long.
And thank you to our audience for the questions, and we'll see you online in the future. Thanks so much. Bye-bye.